Hello student, going to solve physics question paper of November 2023. See link at description for previous year solved question paper. 1. A force of 6 Newton act on a body of mass 4 kg at rest, due to which the body attains a velocity of 30 meter per second. The time for which the force acts on the body is b 20 second. 2. When velocity of a body is double, its kinetic energy is increased by b 300%. 3. SI unit of electric flux is b voltmeter. 4. Capacitance of a parallel plate capacitor with air between its plates is 40 microfarad. Its capacitance with a dielectric medium of dielectric constant 5 between its plate will be C 200 microfarad. 5. Two straight parallel conductor carrying current in same direction will exert a attractive force on each other. 6. If an AC circuit containing resistor only, then D. Voltage and current are in same phase. 7. Total energy of an electron revolving in the nth orbit around the nucleus of an atom varies C. Inversely with n square. 8. Photoelectric current is directly proportional to the A. Intensity of the incident radiations. 9. In n-type semiconductors, donor level is B, just below the bottom of the conduction band. 10. The frequency of the output signal of a full wave rectifier is C, double the frequency of the input signal. 11. What is meant by positive and negative work? Write one example of each. When force applied and displacement in the body are in same direction, work is positive, while applied force and displacement are in opposite direction, work is said to be negative. Example 1. Work done by applied force while pulling a bucket out of the well, positive. Second, work done by gravitational force, negative. 12. What is meant by thermodynamic equilibrium? How do the microscopic properties of the system change in thermodynamic equilibrium? A system which exhibits thermal, mechanical and chemical equilibrium is said to be in thermodynamic equilibrium. The microscopic properties of the system do not change with time in thermodynamic equilibrium. 13. State Pascal's law. Mention its two applications in everyday life. Pascal's law states that when pressure is applied at any part of an enclosed liquid, it is transmitted undiminished to every point of the liquid as well as to the walls of the container. Two applications: 1. Hydraulic pressure, 2. Hydraulic lift. 14. Why infrared waves are also called heat waves? Write one practical applications of these waves. Infrared waves are also called heat waves because they are produced by the hot bodies and molecules. They are readily absorbed by the most materials and increases the temperature. Practical application: physical therapy, infrared photography. 15. A charge q1 is equal to plus 12 microcoulomb is placed at a distance of 20 centimeter from another charge q2 is equal to plus 6 microcoulomb, where a negative charge q3 should be placed on the line joining q1 and q2 so that the charge q3 does not experience any force. Pause the video and see the answer. 16. Define decay constant. Write its SI unit. Decay constant is defined as the ratio of the instantaneous rate of disintegration to the number of radioactive atoms present at that instant. SI unit per second. 17. State the shape of the path followed by the charged particle in uniform magnetic field when it enters with definite velocity at an angle 1 0 degree, 2 90 degree, 3 between 0 degree and 90 degree. What will be the change in the speed of the particle in each case? 1 straight line, 2 circular, 3 helical. 18. Magnetic flux linked to a coil at any instant t is given as phi is equal to 3t square minus 16t plus 4 Wb, where t is in second. Calculate the induced EMF produced in the coil at t is equal to 2 seconds. Pause the video and see the answer. 19. Draw IV characteristics of a Zener diode. Write the characteristic property which makes it suitable for use as a voltage regulator. Pause the video and see the answer. Characteristic property: after breakdown voltage, a large change in current can be produced by almost insignificant change in reverse bias voltage. 20. In a hydroelectric power station, 10 to the power 6 kg of water is falling through a height of 51 meter in 1 second. 1. Calculate the work done by the falling water and potential energy of the water at the top of the dam. Second, how much power can be generated if there is no loss of energy due to frictional forces? Pause the video and see the answer. 21. State the basic difference between isochoric process and isobaric process. Draw the PV diagram for an isobaric process and find out expression for work done when volume changes from V1 to V2 using this diagram. Isochoric process. 1. Isochoric process is a chemical process that takes place in a thermodynamic system under a constant volume. Isobaric process. 1. An isobaric process is a chemical process that takes place in a thermodynamic system under constant pressure. 2. There is no change in volume. Delta V is equal to 0. Second, the change in pressure or delta P is equal to 0. 3. The process changes according in an isochoric process. 3. The pressure of the thermodynamic system remains unchanged during an isobaric process. Pause the video and see the answer. 22. There is always an excess pressure on the concave side of the curved liquid surface. Justify the statement, hence derive an expression for the excess pressure inside a liquid drop of radius r. Excess pressure on concave side of a spherical surface. Consider a small surface element with a line PQ of unit length on it. If the surface is placed, that is theta is equal to 90 degree, the surface tension on the two sides tangential to the surface balance and the resultant tangential force is 0. If however the surface is convex or concave, the force due to surface tension acting across the side of the line PQ will have resultant force R towards the center of curvature of the surface. Thus, whenever the surface is curved, the surface tension give rise to a pressure directed towards the center of curvature of the surface. This pressure is balanced by an equal and opposite pressure acting on the surface. Therefore, there is always an excess pressure on the concave side of the curved liquid surface. Spherical drop. A liquid drop has only one surface, that is the outer surface. Let R be the radius of a small spherical liquid drop and P be excess pressure inside the drop. Then P is equal to Pi minus Po, where Pi and Po are the inside and outside pressure of the drop respectively. If the radius of the drop increases by delta R due to this constant excess pressure P, then increase in surface area of the spherical drop is given by delta A is equal to 4 pi R plus delta R square minus 4 pi R square is equal to 8 pi R delta R, where we have neglected the term containing second power of delta R. The work done on the drop for this increase in area is given by W is equal to extra surface area is equal to T delta A is equal to T into 8 pi R delta R. If the drop is in equilibrium, this extra surface energy is equal to the work done due to expansion under the pressure difference or excess pressure P. Work done is equal to P delta V is equal to P into 4 pi R square delta R. On combining equation, we get P into 4 pi R square delta R is equal to T into 8 pi R delta R. Therefore, P is equal to 2T by R. Or what are three forces acting on a spherical body falling through a viscous medium? Obtained an expression of its terminal velocity. Let us consider a spherical body of radius r and density rho falling through a liquid of density sigma. The forces acting on the body will be 1. Weight of the body W acting downward, 2. The viscous force F acting vertically upward, 3. The buoyant force B acting upward. Under the action of these forces, at some instant the net force on the body becomes 0. Then the body falls with a constant velocity known as terminal velocity. We know that magnitude of these forces are F is equal to 6 pi eta r V0, where V0 is the terminal velocity, W is equal to 4 by 3 pi r q rho z, B is equal to 4 by 3 pi r q sigma z. The net force is 0 when object attains terminal velocity, hence 6 pi eta r V0 is equal to 4 by 3 pi r q rho z minus 4 by 3 pi r q sigma z. V0 is equal to 2 r square rho minus sigma z by 9 eta. 23. Two tuning forks A and B were sounded together give 5 beats per second. When tuning fork B is loaded with little wax and again sounded with A, 3 beats per second are observed. Find the frequency of tuning fork B if frequency of tuning fork A is 480 Hz. Let the frequency of tuning fork B is Vb, given Va is equal to 480 Hz. Possible two frequencies of tuning fork B are 485 Hz or 475 Hz. Since 5 beats per second are produced, on loading tuning fork B with wax, its frequency will decrease, and for 3 beats per second beat frequency or frequency of tuning fork B must be 485 Hz. If frequency of B is taken 475 Hz, then on loading it will reduce and beat frequency should increase. Hence, it is not the possibility. See link at description for previous year solved question paper. 24. Why does white light get dispersed when passed through a prism made up of a material of refractive index mu? Out of red and violet colors, which color will deviate more and why? When white light is passed through a prism, light of different color travel with different speed. It is because the refractive index is different for different wavelengths. The deviation produced by the prism depend on the refractive index. Therefore, on passing through prism, different colors of white light deviate through different angles. Hence, all 7 colors of white light traveling with different speed are refracted through different angle and are thus separated. Violet color deviate more. 25. State Brewster's law. Using suitable diagram, derive the relation between Brewster's angle and refractive index of the material of the medium. Brewster's law states that the refractive index of the transparent medium is equal to the tangent of the angle of incidence for which reflected beam is maximum plane polarized. When an unpolarized light falls on glass, water or any other transparent material, the reflected light is in general partially plane polarized. Unpolarized light AO incident on a glass plate. The reflected light is shown by OR and the transmitted wave by OT. When the light is incident at polarized angle, the polarization is complete. At this angle, the reflected and transmitted rays are at right angle to each other. The polarizing angle depends on the refractive index of the material of glass plate on which the beam of light is incident. The relation between R and IP is obtained by using Snell's law. Mu is equal to sin IP by sin R is equal to sin IP by sin 90 minus IP is equal to sin IP by cos IP is equal to tan IP. 26. Calculate the energy released in the nuclear reaction given below. 10 B5 plus 2 D1 3 4 He2 plus Q. Pause the video and see the answer. 27. Explain the working of NPN transistor in common emitter configuration as an amplifier with the help of a circuit diagram. Write expression for voltage and power gain. Working in the positive half cycle of input alternating potential, the potential of base with respect to the emitter become more positive, due to which the emitter current increase. With the increase in emitter current, the collector current also decreases. As a result, the voltage across the load resistance also increases and the collector voltage become less positive. On the other hand, in the negative half cycle of input potential, the base voltage with respect to the emitter becomes less potential, due to which the emitter current decreases. With the decrease in emitter current, the collector current also decreases, due to which the voltage across the load resistance also decreases and the collector voltage become more positive. In this way, in this amplifier, the phase difference between the input and output potential is 180 degree. The voltage gain is defined as the product of the current gain and the ratio of the output resistance of the collector to the input resistance of the base circuit. Current gain beta is equal to delta IC by delta IB. Delta IC is equal to change in collector current. Delta IB is equal to change in base current. Voltage gain for common emitter configuration is AV is equal to beta RC by RB. 28a. State the law of conservation of linear momentum. Prove it for an isolated system of two bodies A and B using Newton's third law of motion. In an isolated system, the vector sum of the momenta of bodies remain constant. This is called the law of conservation of momentum. Newton's third law can also be used to arrive at the same result. Considered an isolated system of two bodies A and B which interact with each other for time delta t. If FAB and FBA are the forces which they exert on each other, then in accordance with Newton's third law, FAB is equal to minus FBA, or delta PA by delta T is equal to minus delta PB by delta T. Delta PA plus delta PB is equal to 0. Delta P total is equal to 0, P total is equal to constant, that is, there is no change in the momentum of the system. In other words, the momentum of the system is conserved. B. So that Newton's second law is real law of motion. Second law is the real law of motion. This can be proved by showing the first law and third law are contained in second law of motion. 1. First law is contained in second law. According to the second law of motion, F is equal to ma, F is equal to 0, that is A is equal to 0. That is, if no force is acting on the body, then its acceleration is 0. Means if a body is at rest, it remains at rest, and if the body is moving in a straight line with constant velocity, it continues to do so. This is what the first law states. Hence, first law is contained in the second law. Second, third law is contained in second. According to the second law of motion, F is equal to dp by dt, F is equal to 0, P is equal to constant. That is, in the absence of external force, total momentum of system remain constant. Let us have an isolated system of two bodies of masses m1 and m2. Let F12 be the force exerted by M2 on M1 which is action, and F21 be the force exerted by M1 on M2 which is reaction. Let due to F12 the rate of change of momentum of M1 be dpt by dt and that of M2 be dp2 by dt due to force F21. F12 is equal to dp1 by dt and F21 is equal to dp2 by dt. Now F12 plus F21 is equal to dp1 by dt plus dp2 by dt is equal to d by dt. P1 plus P2 is equal to dp by dt, where P is the total momentum of system, since according to second law of motion, in the absence of external force, total momentum of system remain conserved. F12 plus F21 is equal to dp by dt is equal to 0, or F12 is equal to minus F21, hence third law of motion. 29 states Kirchhoff rule of an electrical network. Calculate the currents I1, I2 and I3 in the given network. Kirchhoff first rule, junction rule. It states that the sum of all current directed towards a junction in an electrical network is equal to the sum of all the currents directed away from the junction. Kirchhoff's second rule, loop rule. This rule is an application of law of conservation of energy for electrical circuit. It tells us that the algebraic sum of the products of the current and resistance in any closed loop of an electrical network is equal to the algebraic sum of electromotive forces acting in the loop. Pause the video and see the answer. 30. What are coherent sources of light? Can two independent sources of light be coherent? State two conditions to obtain sustained interference pattern on the screen. Draw the intensity distribution curve in interference pattern and explain how energy is conserved during this phenomenon. Coherent sources of light are those sources which produce the waves of same wavelength or frequency either in same phases or with constant phase difference. No. Two conditions. 1. Waves should be of same wavelength or frequency. 2. There should be no phase change during propagation. The energy which disappear at the dark fringes reappear at bright fringes, therefore energy remain conserved and varies between 4a square and 0 for two waves of amplitude a each. Or what is meant by diffraction of light? Write an essential condition to obtain diffraction pattern. Draw a diagram showing intensity distribution in diffraction pattern obtained due to a single slit. Obtained an expression for the angular width of central maxima in the intensity distribution pattern. Explain why width of principal maxima is twice the width of other fringes in the pattern. The bending of light around the edges of an obstacle is known as diffraction. Condition: the size of the obstacle or aperture should be of the order of the wavelength of light. From figure it is evident that the angular width of the central maxima is equal to pi minus pi is equal to 2 pi. Angular width of other maxima 2 pi minus pi is equal to pi. Therefore width of principal maxima is equal to twice the width of other maxima. See link at description for previous year solved question paper.